Kia ora and welcome to the screencast for Workshop 6. So this one's meant to be sort of a little bit of fun and good practice for us. So we're looking at 3 problems with some new data. So we're going to be looking at the New Zealand Transport Authority, Waka Kotahi's fleet data. So they hold data on the vehicle fleet in New Zealand. And it's a very large data set, over 1 gigabyte, and we're just going to be looking at a smaller subset, but the code, of course, that we'll be using would apply to the whole lot. And so we're going to be doing 3 things. We're going to be reproducing this chart here of the rise of orange and the demise of brown and gold. This is vehicle cars, the percentage of cars and vans over time. We're going to be looking at whether Ford Rangers are really a rural vehicle. And we're going to be finding the former MP for the Wairarapis, former Ute. Right, so I'm going to start by loading the lab sheet up. So here we have it here, and we're going to start by reading the data in. This will take a wee bit of time because it's reasonably large. We've got 849,000 rows and 12 columns. And so you can see we've got the colour, the body type, the CC rating, the gross vehicle mass, the make, the model, the motive power, number of seats, power rating, the TLA, which is the Territorial Local Authority. So that's like the Territorial Authority in the roll data, the schools data rather. We've got the vehicle type, we've got the vehicle year. So we're going to be using this information to answer those questions. So the first thing we're going to do is reproduce this chart. And the chart uses only passenger cars and vans. So we're going to have a look at the cars and vans data, which you'll see that it is most of it. We've got 719,000 observations. So we've only got rid of a few things. And so if we have a look at the chart, we can see that what we have here is we have vehicle colours as panels on the chart. So we're going to be doing some facet wrapping by the vehicle colour. We've got the year on the x-axis, and then we've got the percentage of cars and vans, which is presumably the percentage of each colour. So the first thing we're going to need to do is find out the percentage of cars and vans of each colour for each year. And so we can do that as follows. So we're going to take the cars and vans data, and we're going to group by the vehicle year, right, which is going to end up being our x-axis. And then we can count the basic colours. Right, so that'll give us the counts. Cars and vans, isn't it? So that'll give us the counts, so the number of rows of each, and each row is a vehicle, so that's fine. So this is the number of vehicles of each vehicle year in each colour. And so now we want to convert this to a proportion. So to get proportions within each vehicle year, we're going to have to take the N here, and we're going to need the total, right? So we're going to create a new column for the proportion. So that's going to be a mutate, right? And we can use N divided by the sum of N. So the sum here is going to be done within each vehicle year, which is what we want, and then we'll end up with the proportion. So here you can see that of the cars in 1990, 13% were black. 13% were blue, and only a small amount were cream, and so on. Okay, so that's the way to compute the proportion by year. So we're relying on the fact that it's grouped by year to work this out, right? You could break this down and do kind of in 2 steps if you wanted to. You could do the total for the year, which would just be the sum of N, and then you could work out the proportion, which would be N over the total. Right, to sort of see how the arithmetic's happening. So the total for the year, you can see for 1990, it's all the same number, 14,214, and then 1991 we get a different total, of course, because there's different numbers of cars. Probably more because presumably the population is growing, the number of cars is getting more popular, and so I believe New Zealand has the most cars per population in the world. Right, so we've got our proportion now. Excellent. So let's save that. So this is prop by year and colour. Right, and we'll spit that out again just so that we can see it. And so now when we look at our chart, we have the proportion on the y-axis, the year on the x-axis, and then the colour is the facet is done by faceting. So let's start our chart by setting that up. All right, so we're going to do a ggplot with that data, our prop by year and colour, and then we're going to be doing what type of plot is it? Let's go back and have a look. So this is a line chart. So it's like points, but they've been joined by lines. So let's do a line chart. So that's geom line, and we're going to go, our mapping is going to be, X is going to be the vehicle year, Y is going to be our proportion, and then we are going to be facet wrapping by the basic colours. Okay, so there's our basic chart. And you can see that we're actually pretty close to the real thing already, aren't we? So if we compare it to the actual one, then we can see there's a few things different. So we've got a title. Our year's the same, but we don't have a vehicle year label down here, so we can turn the X label off. Our Y label needs to be percentage of cars and vans. The y-axis needs to be in the percentages rather than in proportions here, and we've got a title, right? So let's have a go at this. So we're going to take the code for the same plot, and we're going to just do sort of bit by bit fix everything up, right? So first thing, easy things, is labels, right? So X doesn't have one. Y was percentage of cars and vans. It's percentage of cars and vans, yep, that's right. And then we've got a title, which is the rise of orange and demise of brown and gold. And then we've got a subtitle, which was car and van colours in New Zealand. Alright, so let's get that up and running. Okay, so that's got the title sorted. We've got this x-axis to fix, and then we've also noticed that we're using a different theme here. Okay, so we could play around with the different themes to try and get that right. So let's try theme, let's have a look. So it's not a grey theme. Perhaps it might be, is it light? Let's have a look. Well, that's similar, but not quite the same, is it? No. So just play around with them until you find the right one. I think it's theme BW. There we go. That looks right to me. The chart looks correct. So the only thing left now is the percentage of cars and vans is done in actual percentages. So we could Google. So ggplot, change axis to percentage. So how can I change y-axis? I mean, let's try this one. geeksforgeeks.org, maybe. Okay. Yep. So here's one where we've got a probability type thing up here, or a proportion. So here we go. So we can use scale y continuous, and we use labels from scale percent. Let's try that. There we go. Perfect. Worked first time. Excellent. I think the sort of short form is actually label percent. I think is the sort of the canonical way of doing it now. So scale y continuous labels equals scales label percent. It's the same way that we changed it to label comma. You may have seen that on some of the slides, particularly for the E. coli data, to use numbers rather than scientific notation. Okay, so that's how we change the graph, and we're done at this point, right? So reproducing a plot is always done the same way. You sort of get the basic plot up and running. You get the x-axis, get the y-axis, get the geometry right. Getting the faceting done, sorted, and then once that's done, you then start looking at things like colors or fine-tuning the labels or the axes and so on to try and reproduce the figure. Okay, so the second one we're looking at is whether Ford Rangers are a rural phenomenon. So of course the Ford Ranger is a ute, and so we're pulling out body type is utility, and we're looking at just recent years. So we're looking at since 2015, and we're creating a new variable called type here, where the make is Ford and the model is Ranger. So if the make is Ford and the model is Ranger, we're going to call it a Ranger, otherwise we're going to call it another. So this is just basically recategorizing the vehicle type into Rangers versus everything else. Right? So if we have a look at utes, then obviously there's a bunch of different makes of utes, right? And different models of utes. But we're specifically wanting to look at the Ranger. Okay, so we're not interested in the Amarak or the Navara or the Hilux, but you might want to do the same chart for that as well later on if you want. Okay, so we've got this new column type here, which is set to other if it's not a Ford Ranger and Ranger if it is. Okay. Right, so the first thing we're going to do is calculate the proportion of utes that are Ford Rangers for each TLA or territorial authority. So you'll see here that we've got the TLA, and the idea is the TLA is a proxy for urban or rural, right? Because we can spot the name of cities in here, right? So things like the Carterton district. Carterton is a small town in the Wairarapa, right? That's typically that's generally a rural location, right? So obviously there's a town there, so there's an urban centre, but it's a small urban centre that is supporting a larger rural area and so on, right? Whereas Christchurch City is very much an urban area, okay? Right, so calculate the proportion of utes that are Ford Rangers for each TLA. Okay, so we need the proportion of this column by TLA. So we're going to group it by TLA first and count. Right, so we're going to take our utes, we're going to group it by TLA, and then we're going to count the type. Right, so that we have, for each TLA, we have the number of other and the number of Rangers. Right. And then we also want to compute the proportion. So noting that we're still grouped by TLA, right? The groups is by TLA, we can convert to proportions with a mutate. It's just going to be n divided by the sum of n, right? Oh, so the proportion, we don't know that they're ranges, I suppose. Right, so we can see that within the Ashburton district, 70% of the utes are other, and 29%, 30% of utes are Rangers. Okay. Right. So now we're going to use this proportion information to produce a bar chart. So the goal is to see how those proportions vary by TLA. Okay, so using only the proportions that can correspond to Ranger rather than other. So we're only using the Ranger rows, so we'll do a filter. The idea being that the other, of course, is just 1 minus the ranger proportion, isn't it? So we're going to take our code from above. Right, and then we're going to filter down to only the ranges. Right, and this is the proportion of utes that are rangers in each TLA. Okay, so now we're going to do a plot of that. So we want a bar chart. So we're going to be doing a column chart because we know what the proportion is. That's going to be the y-axis. So x is the TLA, y is the proportion. Okay. Here we go. So there's our proportion of ranges by TLA. Now, the problem here, of course, is that TLA is a grouping variable that has very long labels. So this isn't an ideal chart, but we might want to switch the role of the x and y as a simple way around this, or you could reorientate the label so that it's vertical. But I think I like switching the x and the y better. So let's switch the x and the y. There we go. Now we can see the various districts. Okay. And so we can see that there's some variation in the proportion of utes that are forward rangers by TLA. Now we might, so these have been ordered in alphabetical order from A up to W, so it's kind of reverse alphabetical order, I guess, in the way that you might read it. And alphabetical order doesn't really make any sense, right, in terms of, I mean, it's an arbitrary order in terms of district. Like it would be, you could order these in many different ways. One of them, for example, is you could order them north to south. Might be one way of doing it. If you had the some information on where these places were, that might be a way to do it. Although you'd need a familiarity with the map of New Zealand in order to then look at the chart, right? If you were looking for a particular TLA, you'd have to know where it is in the country. The other thing is we may just order it by these bars, right? The length of the bar. Because what we really want to know is which regions have a high numbers of or a high proportion of forward rangers. So we can do that with factor relevel. So if we take our TLA, which is ordered arbitrarily, and we relevel it, or is it reorder? I think it's reorder, isn't it? Reorder is the one I want. So relevel is for changing the order manually. We want to do it automatically based on another variable, in this case the proportion. Right, so when I run that, you can see that it hasn't actually changed anything in the data, but the TLA variable is now a factor. Before it was a character. And when I plot it, I've now not changed anything. That's not very useful, is it? Maybe I need to do the reordering specifically inside the Y. Let's try that. That's done it. So it seems as though, interesting, that that ggplot was ignoring the order of the... no, I see the problem. It wasn't ignoring the order. This code wasn't actually working. And the reason why this code wasn't actually working is because we were grouped by TLA still. So the mutation was happening within each TLA. And of course, each TLA is only a single row. So we were reordering the TLA within its own row. And of course, there's only one. So we were not changing the order of TLA at all, because within each TLA, there's only one of them. You can't change the order. So what we would need is an ungroup beforehand. So when we ungroup it and then run that code, it then works. Okay. So this is kind of a common problem. It trips me up all the time, is when you're trying to change something and it doesn't work as you would anticipate. check whether it's a grouping variable. Because if it's a grouping variable, then what you're doing is you're changing that variable within each group. And if it's a grouping variable, then there's only one value of that variable in each group, right? Because you're grouped by it. And so you're not actually able to change it in any way. Okay, so here's our chart. Excellent. We've got our proportion, we've got our TLA. We could maybe tidy it up a bit, right? We could, what could we do? Let's have a look. We probably don't need TLA there, so we could probably get rid of that. So let's tidy these axes up. It's kind of obvious, I think, that these are different regions. So the X would be the proportion of ranges of utes that are ranges. There we go. We might want to tidy this up a little bit. I guess the main problem really is the size of the font, isn't it? So changing size of font can be done with theme. So it is. So this is the y-axis. So axis, and it is the text of the axis. And we could change size equals 10, say. See what that does. Oh, that makes it bigger. Don't want it bigger. Make it smaller. There we go. Okay, so what is our conclusion from this? Are ranges a rural thing, or are they an urban thing? Well, it's interesting to have a look at what some of the territorial authorities are at the high end here. So you can see here that number 2 is Christchurch City, so clearly an urban area. And you can see that that has the second highest proportion of ranges compared to other utes. So folk in Christchurch City, which is an urban area, if they want a ute, they're buying a ranger, or more of them are buying a ranger. Then we do have some rural districts like the Gore district and the Huranui district, but we see that there's some other ones. So here's Auckland here. So Auckland's fairly high up. So again, folk in Auckland, a urban area, if they're buying a ute, they're buying a ranger. And Nelson City's there, that's fairly high up. Dunedin, Hamilton, Gisborne, Lower Hutt, Tauranga, Napier, Wellington, and so on are all sort of in the top half. And when you look at the bottom, some of these places like Thames Coromandel, Waitomo, Otorohanga, South Waikato and Waimate, those are rural places. And folk in those places aren't buying rangers when they're buying a ute, right? They're buying another type of ute. So it does seem that that Ford Rangers perhaps aren't a rural thing, and that perhaps they're more of an urban thing. Okay, so interestingly, folk in cities like Christchurch are typically buying Ford Rangers rather than some other type of ute. Whereas folk in some more rural locations, e.g. Waitomo, Waimate, are buying other types of utes rather than Ford Ranger. So maybe Ford Rangers are more of an urban thing than a rural thing. I mean, there could be tradies and places like that, right? Perhaps folk that are in the building trade prefer a Ford Ranger over some other type of ute. I don't know why, but maybe they do. Okay, so in this last question, we're having a bit of fun in that we're tracking down the former Labour MP for the Wairarappa's former ute. So we've got a data set that consists of all vehicles in New Zealand, or at least a subset of all of them. It doesn't actually have all of them. And so we're trying to find one particular vehicle. So it's sort of a bit of a needle in a haystack type thing. So the first thing we have to do is we're going to have to find out who is the former Labour MP for the Wairarapa and what type of vehicle we're looking for, so that we can sort of have a look through and see if we can find the particular row. So if you don't know, that's fine. Let's use Google to find out who the MP for Wairarapa. MP for Wairarapa. Labour. Okay, and of course we get a very quick hit for the Honourable Kieran McAnulty. So this is Kieran McAnulty. He's currently in Parliament, in the opposition obviously, because he's a Labour MP. The Labour website is horrendously slow. Let's maybe find the Parliament one. Perhaps we'll have a photo on there. There he is there. So that's Kieran McAnulty. Excellent. Right, so we know it's Kieran McAnulty. So let's copy and paste his name. Okay. So the MP in question is Kieran McAnulty. Okay, so now we've got to find his ute. Okay, so let's go back to Google, and we'll find Kieran McAnulty ute. So when we search for this, we get some information. So let's have a look. We've got an article here on stuff. There's a bunch of other ones as well. This one has quite an amusing video with the former Prime Minister. You might want to watch that if you want a bit of a laugh. So we can find out what type of ute it used to be. Here's a picture of it. You may not recognise that type of ute, but we can see that it's red. Okay, and we have some detail here. It's a 1997 Mazda Bounty. Okay, so it is a red Mazda Bounty from 1997. Okay, so that gives us the colour, right, red. It gives us the make, Mazda. We also know it's the Bounty, so that's the model type. And we also have the year. And that's pretty much everything we need to know. The only other thing we need to know is perhaps how many seats it has, roughly. So we could have a look. We can see that it's a double cab, right? There's two doors. So I'm guessing that there's two seats in the front and then probably a bench seat across the back. So it can probably seat 4 or 5 people, right? But you could also just look for pictures, right? There's the Google image search, right? And there's lots and lots of pictures of him with his ute, okay? And there's his new car, I guess, that one there. Anyway, right. It looks like it'd seat 4 to 5 people. Okay. And that's all the information we need, right? So let's see if we can use the fleet data. So not the utes data set, because remember we restricted that from 2005 onwards. And we've got an older ute, 1997. So we've got the fleet data, and then we can just do some filtering, right? So we know that the vehicle year is 1997. Right, so let's check that. There's the vehicle year, all 1997. We've got 24,000 rows, so we've dropped our data set from 800,000 down to 24,000. It's going to be a little bit easier now. We know that the make is, the colour is red. So now we've only got about 3,000 vehicles to look through. We know the body type is, of course, a utility. Because we've got a ute, and now we've only got 250. Okay, so we're almost at the point now where we can just sort of scroll through and find the one we want. We notice that there's still a bunch of different makes. So we've got some Nissans, some Fords, some Toyotas, and so on. So we know the make is a Mazda. So that's even more information. And now we've only got 14 rows. Fantastic. So the other thing is we know he was the MP for the Wairarapa. Okay, and so if you look through the districts here, only one of them corresponds to the Wairarapa, which is the Masterton district. Okay, annoyingly there's two of them. But we can get even better if we say that the TLA is the Masterton district. Okay, now we just have two rows. So one of these rows is that vehicle, and the other one, of course, is not. And if we just look across those rows, we see that it's a B2500, which is the bounty. Same CC rating. Slightly different vehicle masses, which is interesting. And the key difference, of course, is the number of seats. Okay, so we recognised in the photo that this was a double cab ute, and so it had 5 seats. It's not this one here, so we can further restrict it based on the number of seats is 5. And there it is, Kira McAnulty's former ute.